Hello everybody, I'm Callum at Repair Wins, and in the video today I'm going to be fixing an old computer monitor. And when I say old, yeah, it is old. It's about 20 years old, in fact. It's got one of the square screens on it, you know, the old 4:3 aspect ratio, old episodes of Faulty Towers, that kind of thing. How you used to have the border at the side of the screen. Yeah, well, it's that old. But surprisingly, it still worked up until, you know, a couple of days ago. I've since replaced it for the customer because obviously there's no way they were going to pay to have the thing fixed. It's just pointless. And instead of it going to landfill, I've brought it home with me. I'm going to put it on the desk, take it apart and see if we can figure out what's gone wrong with it. So I suppose without any further ado, let's get started. Alright then, let me show you the fault. So obviously we've got this power light down here, and when I plug it in, it's going to stay off. If it was working, it would go green and then obviously stuff would come up on the screen. But let me just plug it in and demonstrate. Right, so it's plugged in as promised. No signs of life. And when it stopped working, the power LED just stayed lit. And not pressing this or using any of the buttons did anything. It just stayed dead. And then I unplugged it, held down the power button, plugged the cable in again, and since that point it shows no signs of life whatsoever. Given this thing was built in June 2005 and it's currently September 2025, I'm willing to bet it's got bulging capacitors. In 2005 was right during the middle of the so-called Capacitor Plague, which I'll put a link to learn more about in the description. But either way, in order to fix this, we're going to have to take it apart. The first thing to do is to remove the stand. I tried to do this at my customer's house so I could carry the thing more easily, and I didn't have much luck. But maybe it'll be easier now that I'm back at my flat. And you would think that this piece just pulls off now, but it doesn't. You know, it rocks about on here, and instead of bore you with me figuring it out, I'm going to figure it out and then come back to you. It turns out there's a little hole here, and there's one on the other side. I'll just put my tool in. Hi everyone, I decided to turn this piece into a voiceover because the audio quality was really low. It turns out that putting a smartphone camera right next to a bunch of clips results in horrible popping noises. But all I did was I put my tool underneath each side, popped it free, and then the cover came off. And as you can see in the video, in order to remove the stand, I just took the 5 screws out. And to stop the stand from flying away, I just supported it. I've actually edited this entire video using this monitor. That was as well as spending an hour watching some old TV with it. You know, 4:3 TV on a 4:3 monitor. There's something really pleasant about that. I've let the customer know it was fixed. They've yet to respond, but the thing is working absolutely fine, and I'm really pleased with the repair overall actually. You know, it's nice to just take some junk parts, put them all together, and make something that works. Here we are then. I just want to show you that there's no screws holding this monitor together. It's clipped the entire way around, and I appreciate it doesn't fully fit in the frame, but yeah, you can see there just clips. Oh no, I tell a lie, there's one screw right down in here, look. But otherwise, there aren't any screws. And these two things for the VGA connector, they are technically holding that in place, so I will remove them. But in the sense of, oh, I'll just take 8 screws out and the back comes off, no such luck. So let me just remove that one screw that I've mentioned, and then I'll get rid of the 2 that are on the VGA connector. And what I'm doing with the screws I've removed so far is just putting them together in little pots, so they're easy to find. But the next step is to remove the bezel, and I'm going to attack from the top, and then I'm going to go down the sides. And I'm going to assume it unfolds at the bottom because that's where the buttons are. So you would never open it from the end where the buttons are. You would always sort of start in the opposite place. Now luckily we're not worried too much about aesthetics, but with that being said, I'm not going to be forceful and break the thing apart just for the sake of it. All I'm doing is feeling around the screen for a weak point, and it might actually be that the back comes off, because if you see there, it looks like it's sort of splitting apart. So we'll just try the back cover first. Although I'm not expecting this to be easy because it never is when the device is this old. Something like a laptop, fine, you've got screws you can remove. But something like a computer monitor, and no, these things are more than happy the way they are. Right, here we go. So I've just made an in. I'm going to work my way up. And I've got some blue plastic sort of clips I can put in here once I pop it open, but there's no point until I get it popped open. Good news, I've managed to get a bit of the way around. You can kind of see what the clips look like. Got this sort of tooth that sticks out at the side. And I've had to do it by just using a silly amount of force. It's more force than I wanted to, but sometimes it's necessary, unfortunately. These old things don't like coming apart, like I say. And if I need to use a lot of force to get it apart, and that means fixing it, and the housing's a bit scratched, then fine. I guess I'm going to have to scratch the housing up a bit, aren't I? I think we're on the home stretch now. Just this last side to do. And yes, ironic that I'm doing the side, even though I said you start at the sides. Well, I said you start from the top actually, and I ended up starting at the bottom. But this is just insane. Like, look, I've got a metal tool, and it just won't go anywhere. So I have to back it up and just risk a bit of damage at this point. And look, I'm bending the life out of my tool. This is silly, you know? There's got to be a better way than this. It has to come upwards or something, but it doesn't feel like it wants to. You know, it's really easy though just to get annoyed at this and force it and then permanently break it. There we go, look. Right, finally! Whoa, that was like 10 real life minutes almost. I've switched the camera angle. It looks rubbish, but you can actually see everything I'm doing now in that slightly creepy wide angle lens mode. And then I can hold that in place and I can do the other tab. There we go. Screen is free, and I should be able to, I'll pick it up like this, because these old screens are bulletproof. It's got a nice strong steel frame. Oh, and look, I broke at least one of the clips taking it apart, but that probably would have broken even if it was a Philips engineer doing it in 2006. They're just thin, okay? Right, and then I can do the same little tabs, and then one more at the bottom. Brilliant. Okay, that's going to come free. And I'm not going to use any force or do anything daft. I want to make sure it is all free first of all. So it certainly seems to be. Yes. Right, this has come away, but you'll notice that the bottom board is attached by a wire. There we go, look. Alright, so we want to get to something called the power supply. I've unplugged that little spare daughter board. And the way, in theory, that we access the power supply is just to take the screws out of here. Awesome, those screws are out. And I'm very lucky because the cover just lifts off, and yeah. Oh, wow. That board has gotten hot at some point. Also, the reason why I was laughing, look at those capacitors. My God, they're more dome than the roof of an opera house. And then this is... this happens to all old boards, by the way. It'll actually be fine. I mean, maybe the transformer's gone pop. I'm very doubtful. If it has, this PCB will be pennies online. But look at all these caps. Wow, even this one here for the auxiliary power supply has failed. That one on the main PCB is fine because it won't have had to do much over the last few years. But regardless, let's get this power supply removed and we'll just check and see what the values of these caps are. Hopefully it's simple enough to remove, just a case of taking 4 screws and a few wires out. So I'll unplug the wires first. And whilst I'm doing this, I do want to stress the importance of basically making sure you know what you're doing. Alright, I don't want to come off as cocky when I say that, but there's a point 5 years ago, or maybe sort of 6 or 7 years ago, where if I tried to do this, I probably would have given myself an electric shock, because this capacitor here stores deadly voltage, so it's up to 450 volts. So it's probably storing 400 at its peak. And then the 2 pins of the capacitor zap, you know, they could be storing voltage that'll kill you, and it'll kill you instantly. There's no recourse, obviously. What, recourse from death? But I am sort of being serious when I say you need to make sure you know what you're doing. You shouldn't attempt a job like this if what I'm saying goes completely over your head, because you're just putting yourself, you know, at really at high risk. Right, brilliant. So the screws are out. And before I can remove the power supply, I need to unplug this connect cable as well, but it's not unpluggable on the power supply side. So I've just snipped this zip tie and I can unplug it on the side of this PCB instead. Right, and I will now, yeah, there you go, this board is going to come out, although it's always fiddly, so I'm going to spend a minute just figuring out how to remove it. There you go. Off camera, I did just check the main capacitor with my multimeter, confirm that it's got no voltage in it, so you know, I'll just poke that and you notice I'm still talking to you. I'm going to put my multimeter into continuity mode so it'll beep when I touch the probes together, and I can use that to test the fuse. And the fuse is absolutely fine, so I can switch that off and put it out of the way. We don't need to worry about the power supply because it's fairly obvious what the defect is. And I was only going to replace the 4 that had failed, so you know, 1, 2, 3, 4. But I've realised that these 2 are the same, and you normally buy them in sets of 5 or 10, so that's not a problem. But these 2 are also the same, and this one hasn't failed, at least it doesn't look like it's failed. But again, you buy sets of 5 or 10, so I might as well do that one. And then these 2 are the same, at least, maybe they aren't the same actually, so I might end up leaving that one. If I've got something in my stash, I'll sort it. But you've got to remember, this is a 20-year-old monitor, it's completely worthless, and I don't want to sink loads of cash into fixing it because I don't even have a use for it. So you see written on my post-it note, I've worked out the capacitors that are needed. 2200 microfarad, 10 volts, 1000 microfarad, 25 volts, 220 microfarads, 25 volts. So the really big ones are the 2200 microfarad. The 2 smaller ones are the 1000 microfarad, and then the smallest is 220. I've found 2 that are 2200 and 10 volts, so happy days. And ironically, they're exactly the same brand as the ones that are on the power supply, although they were obviously built probably at least 10 years later, maybe even more recently than that, so they aren't going to be subject to the same rapid failure the originals were. And I found one that's actually rated 470 microfarad, 25 volts, and you'll notice that's a lot higher than the 220. But in this instance, I really don't see it being a problem. You get sort of a 10 to a 20% tolerance. They're obviously very low quality capacitors anyway, and this one's fairly old. I'm just going to take the gamble. You know, there's a high chance it'll work absolutely fine. Chances are a bit more capacitance is actually a good thing in this instance. Here we go, look, I'm not even going to have to buy any parts, because if I show you this, 25 volts, 1000 microfarads, and that one, and it was in my big box of scrap boards. As you can see, I've got loads of computer and some laptop motherboards in there as well, but also the odd power supply. So this will have come from some Dell monitor, God knows how long ago. Either way, I'm happy I've got it now, because I can take these caps off and we can use it to fix this Philips monitor. I'm going to set about removing the capacitors from this Dell motherboard. This is the best I can do when it comes to the camera work. I've got my soldering station set to 330 degrees, which is low, and that is degrees Celsius, by the way, in case you somehow couldn't infer. And I'm just, the capacitors here, this is called low melt solder, and as the name implies, it's solder with a low melting point. So I'm going to mix it in here, mix it in there, and I'm going to mix it in at the other capacitor, which is much further down the chain, because I might as well do them both at the same time. And it's just got this massive ground plane that's going to soak away all the heat, hence why I'm using low melt solder. Trying to do a job like this without low melt is way harder. You can do it if you've got a motherboard preheater, but I don't. So I'm just going to mix plenty of low melt in. It's fairly expensive, but when you work out the cost per job, it's a few pence, so I just use it sparingly. See, capacitor number 1, nice and easy. Now let's do cap number 2. Nice and easy. I mean, it almost fell out. The way I'm going to do this is I'm going to remove them 2 at a time and then just replace them as and when they need to be replaced. So we're going to do this capacitor here and then that capacitor there. So I'll do the one that's on its own because it's going to be easier to spot the pins. And same as last time, I'm just going to use low melt solder. Right, let's see if that wants to come out. I think it is dropping down. If I just grab it. There we go, it's free. See, low melt solder just makes this sort of thing a breeze. Always better to just confirm where they are instead of removing something you didn't intend to remove. And when I'm soldering it back, I'm going to use lead-free solder. So, low melt is lead-based, but in order to keep this ROHS compliant or whatever, I'll make sure to use lead-free stuff. But there we go. These are both removed, so I'm going to do exactly the same thing for all of the others. Normally I'd clean the PCB, but it's spotless, so there's no point. So I'm going to take my 2 new capacitors, lining up the stripe that means neutral with the mark on the board that also means neutral. Fingers crossed the legs are in the same place, and I will just do the top one first because it's going to be easier I've got more access. So, a bit of finagling, that should go into place. Obviously, you don't want to be pushing down and using silly force, do you? Ah, of course, silly me. Right, I've removed the old cap, so it's not like I've removed the old solder, is it? So, solder wick, as the name implies, wicks away solder. Now, I've seen Sorin of Electronics Repair School do this with old coaxial cable. I don't have any coaxial cable to hand, and if I did, I wouldn't use it, I'd just buy the wick. But if we're lucky, we'll be able to slurp away the solder. You see, this wick is far too thin. And there's big ground planes nearby, so I'm just going to end up sucking all the solder off of the plane and then not actually removing it from where I want to remove it. Oh, no, that has worked, okay. Almost. Yes, brilliant. And it's because I'm using Goot Wick, which is the brand to use, if you ask me. I've increased the temperature on the soldering iron up to 380 degrees, because lead-free solder has a much higher melting point. But that is now going to sit there nicely on the board. So I'm going to have to hold it in place by hand. Put some lead-free on the tip of the iron, and then just put a blob on here. That's what I'm going to do. Right, so as promised, some solder is on the iron. Going to push the capacitor upwards, melt it, that'll sit in place, I'll let go. I'll let it solidify. Then this can go down on the desk. And I'm just going to flow some solder into the other side. All good, that's flowing through nicely, looking good. And now I'm pretty much going to use that procedure on the rest of the capacitors on this board, and I'll get back to you when it's all been done. There we go, they're all replaced, they're all looking... Yes, they're all looking, I think. I was about to say they're looking good there, but that would be a lie. Either way, caps are replaced. I reckon this thing's going to work fine now. Let's get it back together. I've even rolled my sleeves up for this one, look. So, board, hook it under, and put it in place. Neat, board is in place. Let's plug in the connectors. Making sure they seat all the way in there. Brilliant, they're seated all the way down. And I'm just now going to screw the board back in. Oh, before I do, I remember we had this piece, didn't we? And, oh look, this monitor can be run off of a barrel jack. Obviously this one was configured to run off of a mains input, which I would argue is better. But yeah, could run off a barrel jack. Awesome, I put the 4 main screws in, and if you remember, there was a 5th one that helps to earth it, which obviously is absolutely essential. Brilliant, that's clamped down nicely. Next piece is this one. And you can see where all the screws are meant to go. Now I keep them in these convenient yogurt pots, so I'm not going to lose in it. I'll just pour them out onto the top, and then, yeah, we'll whiz through putting all these in as well. That is how that's supposed to go. So we've got these plugged in. Let's just bring the main body of the monitor. We'll plug this connector in and we'll be away. So here's the main body. I can probably pick it up by this piece. I reckon I shouldn't, but you know, the modern monitors literally just use foil tape to hold that on. They don't even bother with screws anymore. They just literally use tape. Well, that's vaguely lined up, and now that it is, I can just plug this piece in. Oh, no, actually, it's going to need to be lined up properly and actually sat down in place. Okay, that's fine. Right, so we'll feel the snaps engage. Well, they haven't made that satisfying pop noise that we like, but they have engaged. And to make this easier to attach, I'm just going to bend these clips out of the way. Take the board off, pull this cable towards me, line it up, plug it in. Cool, that's good. And then this is sat down on the tabs the way that it's supposed to be. Show you the other side as well. Sat down on the tabs. And I'm not going to put the bezel on just yet. I'm going to bring a power cable along and plug this in. We'll see if it works. So if I just flip this up like this, I'm not going to shock myself because, you know, I'm touching the LCD screen. And we'll just plug that in. It hasn't immediately gone kaboom. Right, I don't want to lie it down because that's going to obviously... Oh no, I can lie it down. Brilliant. Alright, I'll lie it down. Power button. No signs of life. My goodness. Oh, there was a PCB I was supposed to plug in, wasn't there? You make the same mistake I do, by the way, and you have to take the thing back apart. Be careful, because this capacitor that was previously dead is now storing a lot of voltage, so I'm just going to keep my hands well out the way of this as I plug this connector in. Right, there we go. That connector is now safely plugged in. They did zip tighten it down in the past, but it's been in the same position for 20 years. I don't need to worry about putting a zip tie on. All I'm going to do is just put this thing back together now. And it's back together again. Plug it in, and this time I expect to see something a bit different. Right, a little popping noise. Still no signs of life on this little board, might I add. Oh, there we go. Ah, boom. There you go, look. Check cable connection. I'm not going to bother testing all of these buttons and making sure they all work, because chances are they were never used. Either way, look, I'll press the power button. Monitor comes to life. I'll just find another, I'll find something with a VGA output and just plug it into this, but I think we're away. We have the one and only Samsung NC10 netbook from August 2008, but astoundingly it has a VGA output on it. I've already plugged into the monitor, and look at that bad boy, Windows 7 Professional, 64-bit Service Pack 1. Believe it or not, if you've seen some of my other videos, you'll know this laptop actually does have a use. But I'm just going to plug into here, and we'll see. We'll turn the monitor on, and think, look at that, it's working absolutely fine. And I want to see what the resolution of this second screen is. Right, so this is 1280 by 1024, nice. How about I slide this thing into frame and we get the bezel put back on. Do the corners. We'll do these corners now. Yeah, there you go, enough persistence, it'll work. And obviously we've got small little gaps here where the odd clip is broken, but this monitor isn't magically going to self-destruct, is it? There we are then, it's all back together. You know, I was actually really surprised by how good the picture quality on this 20-year-old monitor is. And I can't remember what the resolution was exactly, but I know a screen of that quality must have cost a lot of money back in the day. So I'm pleased to see that at least back in 2005, when you spent money, you got quality. These days, you spend money, and you just spend money. You don't get any extra quality as a result of it, you know? Like all televisions, for example, all the cheap ones are built by one company called Vestel in Turkey, at least if you're buying them in Europe. So if you buy a Tesco own brand TV, or a Digihome, or a Sharp, or a Toshiba, or a Polaroid, or whatever, they're all made by Vestel in the same factory, and a different badge goes on them. That's all it is. Whereas back in the day, these companies used to take pride in what they built. They understood that you can't build a company on ripping off your customers and selling them terrible low quality junk, and that if you build quality products that speak for themselves, the customers will come along. There we have it, ladies and gentlemen. This thing now works perfectly, and the best news is I didn't even have to spend any money doing the repair. If you remember, I took 2 caps from a junk power supply and then 3 capacitors from my box of spares down there, basically. I'm going to connect this up to my PC because, believe it or not, it still has a VGA port, and I'm going to spend an hour watching YouTube videos on it just to really test it, but I've got no doubts that it'll work absolutely fine. Either way though, if you found this video useful, or if you just watched it for entertainment or whatever, then feel free to leave a like. That would really help me out. Give more, get more. Like the videos, more videos come out. Like the videos, channel grows, we can reach more people, we can have a greater impact, and eventually, way down in the line, we'll be able to lobby manufacturers and force them to design stuff that doesn't fail, force them to design quality products that last a long time like this one did. If you'd like to see the journey and where we go in the next few weeks, months, years, then obviously feel free to hit subscribe as well. I have another video coming out fairly soon after this one. It's either going to be me repairing 3 Lenovo laptops or me fixing a computer motherboard. So stay tuned for that, and until next time, I will see you later. Take care for now, and goodbye.